Okay. So make sure you're following along here on a separate sheet of paper. Like I said, the title of this mini lesson here is just identifying equivalent algebraic expressions. All right. So we're going to use both of the tools that we talked about last week, either combining like terms or distributing to help us find the final answer. All right. So the first couple questions are going to be a little bit of a review. The second question is going to be a way for us to not only find our answer, but also check. All right. Ms. Smith talked to you about combining like terms, right? And remember that when we're combining like terms, we don't have to worry about the variables necessarily when we're adding or subtracting things together, right? We just worry about those coefficients, all right? And that's the number that's out in front of my variable. So take a second if you need to, jot down part A and B here. And we'll just take it one step at a time. Part A, I have 7x minus 2x plus 7x, okay? Well, if I'm adding those terms together, I'm combining those like terms. Think about what you did at the end of last week. What would my answer be here? If I have 7x minus 2x, what does that give me? Remember that the variable just kind of tags along, and you just have to do 7 minus 2, which is what? 5x, good. And then I have 5x plus 7x. So this is, if we combine maybe the first two, this becomes 5x. I still have the 7x on the outside. Well, let's go through the same process. 5x plus 7x gives me what? If I'm just adding those two numbers in front, the variable tags along, that becomes what? 12x, right? So on your ALEKS assignment, it's going to give you this original expression. And you have to go through the process of writing down, all of the steps along the way. It'll have multiple choice answers across the end here. And they're going to ask you, well, what's equivalent to 7x minus 2x plus 7x? You would choose the answer 12x. Essentially, they're asking you, what is the final answer when you combine like terms? Okay. Everybody understand that? Same goes for part B. Now, this one was probably a little bit easier for us, right? We did a lot of distributive property at the beginning of last week. So let's recall what the distributive property is, right? In part B, I'm going to take the 2, and when I distribute, I'm multiplying those terms together, right? So I have 2 times 1 plus 2 times 3y. Well, what's 2 times 1? Just 2, right? What's 2 times 3y? Remember, I just multiplied the numbers together and the variable tags along. 6y. And can I combine these together? No, right? Good, because one has a variable and one doesn't. I can only combine things that have the same variables attached, right? So that's why I was able to add all the x's together, because they all have the same variable. If a number is just by itself and a number has a variable, I can't combine those. So this is my final answer. Okay. So again, it'll give you maybe a distributive property question, and it'll say, well, what's equivalent to 2 times 1 plus 3y? You would say 2 plus 6y. They're the same thing. You're just finding the final answer. Does everybody understand that? Are there any questions about that idea? Okay. Let's look at another example. So I have 12x. We'll just do part A. 12x minus 6x plus 5x. Okay. Let's take this step by step. What's 12x minus 6x going to give me? What's that? 6x, right? The x tags along. So I have 6x plus 5x. And what's 6x plus 5x going to give me? Everybody just add those numbers together. 11x, good. So my original expression, 12x minus 6x plus 5x, is equivalent to just 11x. Does everybody see that? Are there any questions about how I found that answer? Well, what I want us to do now is check that. So, all right, you're going to go through and you might solve it and you're going to choose that answer. But how do you know that that's the correct answer? One thing that you can do to help you check is to take a number and plug it in for x for each of those two expressions. So your original and your final answer. And you should get the same thing when you plug in that number for x in the original and you plug it in for the final. So for example, I would choose an easy number to plug in, right? Choose 1, okay? So if I plug in x, instead of 12x, I'm gonna have 12 times 1 minus 6 times 1 plus 5 times 1, all right? Well, anything times 1 is just itself, right? So 12 times 1 is just what? 12. 6 times 1 is 6. 5 times 1 is 5. Well, if I go through, 12 minus 6 is what? 6. And what's 6 plus 5? 11. So my final answer over here is 11. Well, notice that if I plug in 1, if I plug in that same number for x in the other expression here, my final answer, what's 11 times 1? Isn't that also 11? So when you plug in that value into both the original expression and the final expression, you should get the same thing in the end. And that's a way for you to check to make sure that your final answer, the correct solution that you're showing is equivalent, is the same, right? If it's equivalent, they should get the same answer out in the end. Does everybody understand that? Are there any questions about that idea? Okay, let's look at part B. How am I going to simplify part B? What do I have to do there if I'm distributing? How do I distribute? What do I have to do? What's that process? We talked about this last week. What do I have to do with this 4? Multiply it by each of the terms inside, right? So I have 4 times 1 plus 4 times 6y. Well, what's 4 times 1? 4. What's 4 times 6y? 24y. So this original expression is equivalent to this expression right here. Okay? So when you go through your homework, you would choose 4 plus 24y. Those are equivalent. Now to check, we're going to do the same thing that we did before, right? I'm going to plug in a number into both the original expression and my final answer and see if I get the same thing out in return. Well, like I said, make sure you plug in an easy number to work with, all right? So I'm going to plug in 1 again. Well, what's 6 times 1? 6. What's 6 plus 1? 6 plus 1 is what? 7. And what's 4 times 7? 4 times 7? 28. So I should get 28 when I plug 1 in to this final expression too. Notice that if I do 4 plus 24 times 1. Well, what's 24 times 1? 24. And what's 4 plus 24? 28. So I got the same value in return. This means that they are in fact equivalent. Like I said, this is a way for you to check your final answer to make sure you're doing the right thing, right? You go through first and you either combine like terms or distribute, and you choose your final answer. Then what you can do to check is just plug a value in. Make sure that you're doing the right thing. Make sure that the answer that you chose is correct, right? And if you plug in that value into both equations, you should get the same answer out in return. Are there any questions about this process? Anything that we covered today? Anything for you to check your answer or how you should find your final answer? Okay.